Hey folks, sorry about the delay with today's video. I was trying to get some recording stuff set up and it delayed it a bit. But today we're discussing Rust Basics 2, and so without further ado, we'll go ahead and get started. So the goals for today is we'll have some short discussion and I'll introduce this idea of vectors. These just might be useful for your final projects, as well as maybe for your MPs here and there if you do decide to use them. We'll discuss compound data types and a little bit more on compound data types. And then we'll really get into the meat of today's lecture, which is these ideas of matching and the sum type, as well as enums. Just some quick reminders. Homework 0 is due tonight, 9:15 at 11:59 p.m. And then MP 0 is due Monday, 9:20 at 11:59 p.m. It seems like people are doing pretty well on them, but of course, if you do have any questions, just reach out on the Discord or attend some of the office hours that we've now posted also in the Discord. Okay, so just some quick recap. With Matt, or Monday, you discussed functions. Of course, the main kind of attributes of functions being, we can utilize this function keyword to create functions that we can call. Same thing here. We can, say, hey, these are some parameters that I want. These are the types of these parameters that I'll be using. And then this is the return type of my function. We can contrast this a little bit with a language like Java, where we might say int, function, func, and we'll have like int x here. And then we'll have our curly braces and have some code here. We can draw some parallels between these. Obviously, these two ints kind of correlate to one another, meaning the return value. These two ints correlate to one another, meaning the type of the parameter, the name of the parameter is all obviously the same, and then we did name our function differently, but keep all that in mind. We also discussed returning. Normally I would say make sure to use the return value, but if you're being lazy or maybe in special cases sometimes it can be a little bit clunky. You don't always have to use the return value. If you just want to put some statement or expression here without a semicolon, this will end up getting returned into this value up here, or whatever the function is called, I should mention. You also learned about comments. I won't talk about these too much. The only thing I'll mention is when you're doing your final project, and as well as when you come to office hours, it's either in terms of office hours good practice to comment your code because it helps us understand, and in terms of your final project, I'll say probably not necessarily required, but if you don't comment in your code, then you'll probably get points off on style. Okay, and then you also discussed arrays and tuples. Arrays, of course, are fixed length with a fixed data type, and the immutable or mutability of their contents is going to depend on the mutable keyword, of course. Tuples, in comparison, are still fixed length, but they can have variable data types. So arrays, for example, could be like 1, 2, 3, maybe all the way to 720. And then tuples could be something like 1, 1.8, the character A, the string A, B, C, all sorts of things, right? Of course, both of these are fixed length. Once you create them, you cannot add a new element in. They're kind of stuck. And if you do want to change an element, just make sure that you have the mutable keyword when you instantiate it. Great. So let's introduce this new idea of vectors. Vectors are similar to arrays similar to arrays in that they have a fixed data type, but they do also have variable length, and so we can now kind of expand or shrink our vectors as we wish. And these are similar to maybe lists in Python, if you're familiar with that. Skip 2 slides there. That was strange. Okay, so first, this is how we create vectors. There's a couple ways, but I recommend you use the vector macro. Macros in Rust, of course, being just these things with exclamation points that do common activities for you. A more common one that you might use a lot is println, which of course is also a macro, and then you call this on some function or on some string. Okay, so we can use the vec macro here in order to instantiate a new vector. We'll just say 1, 2, 3, and we can print, for example, things like vector.length, and that will return 3 here. But of course, we just mentioned the nice thing about vectors is how they can be appended to. And so we'll look at two kind of short ways. First, you can use the push keyword in order to kind of add a new element onto the end. You can extend a vector by a list. So now at this point, our vectors 1, 2, 3, dot, 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 7. Of course, all the numbers are there. And then you can also, of course, remove from vectors. And so we'll have the full example here. We can say v.pop, which is going to pop the last element. Now I will mention, I want you to kind of pay attention here. When we have x, what is the type of x? You might be, pushed towards thinking it is an int, or some sort of like I32, and you would be very close. But notice how I use it. We first have to unwrap it, which means it's going to be a sum type, or an option type, I should say. And we'll get into what the specifics of that are very soon, but those of you who have already started on the MP probably have some exposure to this. So yeah, we did kind of want you all to use the Rust docs a little bit. We want you to be learning on your own as well. We think that that's kind of a key component of this course, is also having you explore yourself a little bit. Okay, so it is of course an option type, so we would need to unwrap it first. The question or why it is an option type is because of what is the case in which this vector is empty. If we attempt to call the pop function on an empty vector, rather than just throwing an error, what Rust will actually do is it will return a none type. And then obviously, if we try to then work with it and like unwrap it into some int and try to use that int, we'll then get an error. But we can also, of course, just check to see if it's a none type before, maybe progressing with a critical part of our program. Okay, and so let's have some reminders on arrays very quickly. And this kind of also applies to tuples and vectors as well. We can instantiate some array with this syntax just using the square brackets. We'll have it be mutable because we'll want to edit in a little bit. And we'll just use the .iter to print each item in our array. Nothing too crazy here. We'll create an array 0, 1, 2, 3, 4. We'll print out each item. We'll change the first item to be 42 and we'll print it out. Okay, so nothing too crazy going on there. But let's have some fun with this. So as we kind of mentioned, the elements in an array all have to be the same, but they can be almost anything. And in fact, they can be other arrays. So in this situation, we have a two-dimensional array with each element in the array being a new list or a new array. I need to be careful with my verbiage here. Maybe I shouldn't call things lists. And then again, we'll have a for loop, or in this case, a double for loop, just to print out each item in the array. And sure enough, this for loop will print out 0, 1, 2, 1, 2, 3, 2, 3, 4. Okay, and a quick question that I want to throw out to you all, maybe we can have some discussion on the Discord about this. Could we have, for example, an array that is of different size? So maybe this first one is 0, 1, 2, 3. I'll just kind of append a 3 there. And maybe this last one is just 2, 3. So this one has length 4, this one has length 3, this one has length 2. Do you think this would be allowed? Why or why not? I won't actually spoil it in this video. I encourage you to actually run this on your own machine and figure it out. A kind of hint is, does this kind of violate any of the rules that we force arrays to have? Okay. So additionally, we can use some shortcuts to speed up development in our arrays. And I just thought I'd show you this because it's kind of nice. So what we can do is have some default value here and say this is how many times I would like to iterate it or have it in my array. And so we'll create an array here that has 4 0 elements, and we'll print each item and we see it has 4 zeros. Similarly, we can do the same thing with a 2D array. So say, hey, I would like to create an array that has 4 elements, and each of those elements is an array that has 4 0 elements. So what does this actually look like? Maybe I shouldn't have done 4 because this is a lot of drawing. But it's going to be a 4 by 4 array with 0 values everywhere. Okay, so I hope you all get the idea there. So we'll move on. Let's talk briefly about enums now. So enums or enumerations are a different type of tool or structure, or there's kind of different things you can call it, that are used in most modern programming languages. And they allow us to enumerate possibilities for a certain thing. And this is kind of how it's structured, is we have enum being the keyword, whatever we want to call this enum, so whatever that thing is, and then all of the options that that thing can take. And it can be any number of values. And just very briefly, since I'm more interested in the hardware side of things, for those of you who are also interested in it, we'll discuss kind of how this is stored in memory usually. So the big question that we have to ask ourselves here is how many elements are in our enumeration. If, for example, we have a total of, we start with 1 in this case. If we have a total of 8 elements, then we can actually represent everything in our array with only 3 bits. Right? So this first element would be the 3 bits 0, 0, 0, 0, 0, 1, dot, 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 1, 1, 1. Right? And so that's, if you're interested in how these values are stored in hardware, this is kind of how. Of course, nowadays in modern programming languages, there will be probably a significant amount of overhead. Not only will you need to store the value, you'll need to store kind of what type of enum it is, and that'll be stored in something, and you'll need to store, maybe some other information along with it. But yeah, so that's kind of the core idea if you'd like to know. And then finally, when we actually want to use one of these options, we can use the same paths as we learned when we learned about modules. And so we start with the enum name, we use the double colon, and then we say the option that we would like. And in this case, I'm assuming there's like some option that's 551st. Of course, maybe there isn't, maybe there is. Excuse me. Of course, if you try to, get an option that doesn't exist, you'll receive an error. It probably won't compile. And then let's also discuss match statements. So match statements are similar to switch statements in other languages, except they're a little bit more flexible. They're a little bit allow us to do a couple more things. And then additionally, they kind of just act to replace if statements and else statements in a little bit more of a concise way that's easier for us to write, easier for us to read. And so the structure for these is the keyword match, the value you would like to match on, the pattern you'd like to match the value to, and then the expression that you would like to execute or evaluate given that this pattern is true, is equal to value. So really what I want to do here is look at one kind of large example that uses both enums as well as match statements. And so let's explore. First, we'll enumerate the states. So we'll say enum US state. Let me shrink my thing down a little bit. Enum US state. And we would type out all the states, but we're very lazy, so we'll just put the first two, Alabama and Alaska. Next, we'll say there's an enum for all of the coins, pennies, nickels, dimes, and quarters. And quarters additionally have this trait that it contains a US state, or it is referenced to a US state. Next, we'll build some function called value in cents, and we'll explore this in a little bit, but let's hop over very briefly to the main function. So when we execute this program, we will call value in cents with coin quarter. So once again, coin takes us to the enum. And then quarter says, hey, I have a quarter of type coin. Might be a good way to say it. And this quarter, because it requires a US state enum as well, needs its own kind of parameter passed into it. And in this case, we say Alaska. Our other option, of course, is Alabama, but that's the only two we actually ended up typing out. So wonderful. So this whole struct, this whole enum kind of option, this whole variable gets passed into value in cents. And just a quick reminder, this is of type coin. And it's of type coin because we got it from the coin enum. Okay, and we'd like our function, value in cents, to return an 8-bit integer, an unsigned 8-bit integer. Of course, in this case, we know by the name of the function that we would like it to return the value of the coin that we have. And so what we'll do is we'll match the coin. So once again, match the value we would like to match, and then the different expressions we would like to match to. First, if the coin is equal to a coin that is a penny, we can return 1, or we can match to the expression 1. If the coin is a nickel, 5. If it is a dime, then 10. If it is a quarter, then we will first print what state the quarter is from, and then we will return the 25. And there's a lot of kind of tricky syntax things going on here, and this is really something that I want to take a moment to explore further. So first, one moment. Apologies. So first, one thing that I want to point out is this function is returning an int 8, yet we have no return statement. So what's going on here? Well, those of you that remember the functions lecture will remember that if we have the last kind of expression in our function that does not have a semicolon, then this is the value that will get returned. And sure enough, the match statement will actually return whatever the matching expression returns as well. That was a little complex to say. But so basically this function is going to return whatever the match returns. Now, what is the match going to return? Well, it depends on which of these we enter. So let's for a moment say that we pass in, instead of a quarter, a penny. In this case, we would match to the coin penny expression, and we would just have 1. And this is its own function in a way, or rather its own expression. And this is the last variable in its own sort of expression. And so this 1 is what gets returned. It is similar in a way, but definitely not equal to having something like this function, penny return, where we're passing in any parameters here. Of course, we're not actually passing any parameters here. And we just have 1. And that's it. Of course, no semicolon, or else it wouldn't return. I apologize for the poor mouse handwriting, but I hope it's legible nonetheless. Same situation for nickel, same situation for dime. The situation for quarter is slightly different. So in this case, instead of a 1-line situation, we need to give it 2 lines, and so we do use the curly braces. And then additionally, we're passing some parameter into here. And so once again, you can think of these 2 curly braces as a function in a way, and we're passing this state parameter into this function. And so we'll print the state that the quarter is tied to. In this case, it would print Alaska. And then we will return the value 25 into the match statement. The match statement will evaluate to 25, and the function value and cents will return 25. And then eventually the main function as well in this situation. Oh, never mind. We have a semicolon. If there was no semicolon, the main function could also return the value that the value and cents function returns. Great. So I hope you all understand this. There's kind of 2 major components to it that I want you to take away, or rather 3. First, how do we use these enum statements to allow our functions to be more legible? Of course, really the alternative to this is saying something like, if you know there's 4 types of quarters, you'd say like 1, 1, and maybe you have like literally the binary 1, 1. I'm not quite sure the right way to write this, so we'll say binary 1, 1, and then Alaska would be like binary, let me think, 64 would have to be 6 bits, and it's the second thing, so 0, 0, 0, 0, 0, 1. And obviously, like, this is, probably significantly less legible and understandable than coin quarter US state Alaska. It's very clear which is easier, and when you tie these together into, very large things, it can make a huge difference. As a quick aside, I actually, just to point out kind of how useful enums are, have recently been working on my ECE 411 MP, where we were building a ISA based off of the RISC-V architecture, or ISA, I guess. And basically what this means is each of the operations that a CPU can do is encoded in some binary format. Maybe this is equal to like add 2 numbers together, and maybe this is equal to like, hey, go load some data from memory. And of course, hopefully you can kind of see how this correlates to an enumeration. If I actually had to directly work with binary each time, I think I would tear all of my hair out. So instead, I have a big file with a ton of enumerations saying, okay, add, load, store, subtract maybe, even though this is a little bit similar to add. Et cetera, et cetera. So, enumerations are super useful, sometimes even necessary. I would highly doubt that I would be able to get my projects done if I did not use these. So I encourage you in a lot of cases to ask yourself if using an enumeration is the right situation. Okay, and then a final quick note on matches. Matches can be exhaustive, but we can use placeholders. So what I mean by this is when we enter a match statement, something needs to match. We can't kind of enter and exit without something matching. But we can use the underscore placeholder to say, okay, everything else will match here. Okay, and so in this specific scenario, we will create some number. In this case, we'll start with 15. We'll match on x modulo 3. If it is 0, then we'll print fizz. Else, basically, we'll print nothing. If it is 5, we will print, if x mod 5 is 0, we'll print buzz, else we print nothing. And you might ask yourself, could I do this with if-else statements? And in this specific case, yes, and it would probably be easier. In fact, you could do it with a single if statement. If this, if that, right? However, I would like to ask you, what if the case that we're doing x mod some number that we do not know, and maybe we have 100 of these cases? Then it gets significantly more complex. And in fact, a match statement is much more of a better way to do it. I mean, it becomes many, many, many times more legible. Okay, and of course this example would print fizz buzz. If this number were, for example, 3, x mod 3 would equal 0, so we would print fizz. X mod 5 would equal 3, and of course 3, in the case of 3, we do nothing. And so we would move on from that statement. So we would just print fizz. Great. And I'll talk about one last thing here, which is the sum and none option types. And for those of you that have started the MP, again, I mentioned kind of very briefly that you might have been exposed to these, but let's dive into them a little bit deeper. Sum and none represent the possibility of some value. And so I want to just drive your attention to this here. Just a quick example. Say we have some function that probably is going to return some value, but we're not sure. Maybe we're getting some user input. Maybe we're reading some memory that may or may not be there. Maybe, it can be sort of many, many things, right? Maybe some other function could have errored out and we're not sure, right? We want to be able to handle the case that this will return a value or not. And so we can say that instead of returning an int32, this function will return an option int32, or an option of type int32. And then we can deal with it kind of very similarly. So in the case that we have sum, we can print, let's start here. So we call this function and we return some value. First, we'll explore the case where we have none. So this function, again, no semicolon, it'll just return none to x. So at this point, x is equal to none. When we match x, we'll of course match none, and we'll just return nothing will happen. And that is the case we see here. However, instead of none, let's say for a moment that this function returned sum, and let's say 5. Again, no semicolon so that we can return it. This function will get placed into x. We'll call the match statement on x. It's not equal to sum 42. However, it is equal to some x value. And so then we'll call this here, and we'll print at 5, and then this little maybe disappointed face with the value x. Once again, remember that x is sort of like a parameter to this function here. This expression maybe is a better term. And then finally, let's explore the case of sum 42. This value gets returned to x. We match sum 42 is equal to sum 42, and we can print 42, and maybe this time with an exclamation point. Okay, so I hope you all understand a little bit about this sum and none type and how they're used. They can be a little bit more complex just because people or other languages don't really use these. However, they're super helpful, and in fact they're incredibly useful in a lot of cases. So I encourage you to try to use them and really understand them. I think in terms of true complexity, they're actually quite simple. They just really represent maybe a thing is here, maybe a thing is not here, and you need to check. One other thing that I'll mention is if you want to do something with this value, you can also occasionally need to call x.unwrap, which basically converts option int32 into int32. You can think of unwrap doing that. Of course, you might ask yourself what happens if you unwrap a none type. Bad things. You'll probably error out. Potentially the compiler will catch it in certain cases, but attempt to not do that if possible. Wonderful. So we're at about time now. I hope you all had a wonderful week. Don't forget, homework 0 due tonight, MP1 due the 20th. Have a wonderful rest of your week. Have a wonderful weekend, and I will see you all during my next lecture. I believe Matt is next doing ownership, which is a nice idea in Rust that helps with memory management. So, bye-bye.